Lesson 5. /post1 is the command that puts ANSYS into the general post-processing mode. I copy this command and paste it here. It's like you just click general post-process. So set last. It load the final result set. Copy this again and paste it here. PL like plot, N nodal, SOL solution. What is S? It will plot equivalent or von Mises stress at nodes. So you might ask, why S? S stands for means stress results, and 0 means default display setting, like no specific rotation, and 1 here is a scale factor for the deformation. So copy this and paste it here. Plot nodal solutions. Yes, it will plot. And *VGET. This command stores the von Mises stress at all nodes into an array. So *VGET, as we discussed in previous lessons, is a special APDL command to fill an array with data. And res_1 is the name of the array you are creating. And nodes tells it to pull the data from nodes, not elements. And here we have a blank field, means all nodes. All nodes, remember, this is important. It means all nodes. And SEQV again refers to a stress equivalent or von Mises. And the last two tells the APDL to store nodal average value, as I remember. So let us copy this. Before that, let us check array parameters. So we have one here. Yes, we stored all of the von Mises stresses. So now the question is, you have 37 files here. And remember, our current directory is 14. You can find it from here. It's 14 or the other way. And I will use file read input from read nodal 1. And then it will create res1, all of the nodal. So what is this file actually? So we use *MWRITE, res1.txt, ijk100, comma 1,1. This is a multi-write command. It writes a vector or array. Here it's res_1. I will call it res1. And this is the array you created earlier. Remember, you created this one earlier before. You should have done that before. And it contains the nodal von Mises stresses. It could be a strain energy or whatever if you extracted it. And this is the name of the output string. APDL will create a file called res1 and txt. is the extension, and here I think it is related to the directory. I usually don't use this, but it is better to work on this and let me know what will happen if you put the directory name here. And IJK, this controls the writing format. I explained this before, and 100 is the number of the values you want per lines, I think. So let us see again. We have 100 values here. I will change this name to res11 and Control S. Remember to save this file and do it again. I also, it's much better also to do, yeah, I also put res11 here. So Control S, file, read input from. Read nodal one. Let us go back to the folder. Why it didn't create anything? Because the name of the txt file was different. Now I will run it again. I changed it to res11. But if you go back to the APDL parameters, we have res11. It means that this is correct. And also, let us make another change to 1000, for example. Control S. And go back here. It is 1000. Can we save all of them? I will copy this. Scalar parameters. $591 kilobytes. So 595. 595. Yeah, you can do it easily. You see. So now one of the question is, do we need to plot the nodal solutions? So I will answer these questions easily. So I ran the file again, and we have 40 files here. And we want to use read input from and read this file. Now we have, we don't need to actually run this part. We don't need this command. Okay. But it will plot the nodal solutions for you. There might be one question why we don't need CF open and CF close. So MWRITE, it will open the file behind the scenes and it will close the file automatically after writing the entire array or vector into it. So you just need a star VGET and a star MWRITE. Okay, we have 41 files here. And in the parameters and array parameters, we have 2 files. So now let us use file read input from and read nodal values. Actually, now it is not read nodal values. And we want to see what happened. Okay, we have this file. I just use Control S and save this file. File read input from. Oh, SE is not recognized. Why? So the reason is we need to have this file, this line, eTable SENE. Ensure that the element table SE is created before you use eTab SE. Let us run this, then I will explain the whole code. So we have a strain energy. And we have a strain energy here. How many we have? Let us see. 100. But here it's 27,071. So what is this number? This is the max ELEM. Or you can use this code to get the number of elements. Max LM is the same and num elements is the same. So we change it to num LM. Now it is 27,072. And remember, for 1 mycel stress, when you go to the list result nodal solutions, in the 1 mycel stress, the number of data here is the number of the nodes you have, because for each node you have a corresponding 1 mycel stress. So let us change and fix this code actually. Nodes 33,595 lines, which is exactly the value of the number of the nodes. Okay, now I will add part 3 and 4 to this code. I want to get a stress at x, y, z, x, y, y, z, x, z, and also strains, and then I want to write them out. So I will save this file, go to here, file, read input from. Let us see what happens. 1, 2, 3, 4, 5. We have 12 new files, 56. Let's open one of them. Let us do a fact check. X component stress. So Sx is, for example, node 3, okay, node 4, Sx. 1, 2, 3, 4. Minus 1.7. Minus 1.7, because this means 10. And the first one is minus 0.66, the same thing. Okay, how to read the displacements? Let us see what would happen if we use read input from. Okay, we have ux.txt again. Exactly. Number of the nodes. So again, star VGET, this command is used to retrieve values and store them into a vector array. X displacement. This is the array where the retrieved displacement data will be stored. Let us show you. X displacement. Yep. And node specifies that the data is based on nodes. And one here, this refers to, I think all of them. Ux, this defines that we are extracting the displacement in x directions. And CF open. This will open a text file. This commands open the file for writing actually. And ux, the name of the output file, it will be ux.txt. So at this point, ux.txt is open and ready to write data into. These lines write the displacement value into the text file. So what about this part? E is exponential scientific format, 16 bits of the number, 16 characters, and 8 is the number of decimal places, 8 digits after the decimal points. This is a placeholder for additional columns, I think. You want to write more values. And CF close. This closes the file that was opened using a star CF open before. For UX and UI, use CF open and CF close and scientific. implementation.